Hey guys, this is going to be our 5.2 notes, and we're going to go over number one and number two. We're going to go over example one right now, A and B. So we're just going to jump right into it. The point of this section is to be able to solve systems by hand or algebraically. So we're not going to be using our calculators on this, no graphing calculators. So here's your problem, here's your system. Your first line is y equals 2x minus 9. Your second line is y equals negative x plus 15. If you remember in the last section, we took the lines, we graphed the two lines, and their intersection point is the solution. So what the computer does in essence, it plugs in a bunch of x's and gets out a bunch of y's. It runs an infinite number of points in its head. It does the same thing for this line. And then it's just basically a guess and check method to where it knows where it crossed itself so it can solve it. No human brain can do that. We can't do two lines, two variables at the same time. So what we're going to attempt to do is we are going to attempt to substitute one of the variables out, solve for one variable at a time. And the method we're going to do this is substitution method of solving systems of equations. Now I break it down into 5 steps. I call it solve, sub, solve, sub, solve. 2 words, you gotta say it 5 times over. So, the first thing we need to do is make sure one of our lines is solved for one variable. You can see here both of our lines are, okay? So we have y equals 2x minus 9 and y equals negative x plus 15. So we're set. I'm going to rewrite those so they color code a little bit. So in blue, I'm going to put y equals, and then I'm going to put what they equal in 2 different colors. 2x minus 9, and then negative x plus 15. So our step 1 was done because we've already solved one of the equations for one variable. Now, what our next step is going to do, we need to substitute one variable out so that we have an equation that only deals with one variable. You can see that the red part equals the blue y. The black part equals the blue y. Well, if this equals y and this equals y, it hopefully should make a little sense that these two things must equal each other, okay? Now, that won't always be the case, so what I want you to focus on is me substituting. This red value for what y is going to be substituted wherever I saw y in the other line. So this was y. I'm going to substitute that y with the value that I know it's equal to. So now I can simply say 2x minus 9 is equal to negative x plus 15. I simply substituted this into the value for y. That is my first sum. Now I'm just going to solve. So I need to get my x's on one side, add x to both sides, draw my line. Now make sure yours should look just like mine. Work from left to right. 2x minus 9 plus x, the x's combined, 3x minus 9 equals, those cancel, which is what I wanted. Now I'm at 15. Now, my x is on one side of my equation. I need to get rid of that negative 9 by adding 9 to both sides. Now my result is 3x equals 24. My last step is going to be divide each side by the coefficient. X equals 8. I just did my second solve step. So everything up till now, all I did was substitute this value of y into that y from the other line. Then I solved it down, because now I'm only dealing with one variable, and I solved it down to where I have the solution for one of my variables. Well, if I know what one variable is, I can always go back to the line and solve for the other one. This line said y is equal to 2 times x minus 9. So I know y has to equal 2 times the x I solved for down here. I know my solution value of x is 8. and then I have my net minus 9 at the end. So y is equal to 2 times 8 minus 9. Y equals 16 minus 9. Y equals 7. I have my x and my y, and I need to write my solution as an ordered pair. So I have my solution as 8, comma, 7. And you can check it here. Remember, if you're a solution to the system, you must work for both. So now it's 7 for y should equal negative whatever x is plus 15. And as we go through, negative 8 plus 15 is 7. This works for this line, and it worked for that line because that's how I found it. So this is my solution, and I checked it. As a quick overview of everything we did. Solved one equation for one variable. That was done for us. We substituted the value for that variable into the other line. Then we solved that equation that was only for one variable. Once we know this variable, we plug it into either line, we substitute it in for either line, and then we're only dealing with one variable, and then we just solve for the second variable.